You ever just feel like you're starting to sound like a broken record? I get that case every time I get a radio like this. Just time and again with these butchered radios. I just don't know what else to say about them. You know, customer sent this one in, was having some display, actually the frequency counter modules unplugged just to get it out of the way. Doesn't need to be in there for the radio to work, other than the display. But he also asked about the transmit audio on this thing. Is there anything I can do about that? Well, okay, well, fixed the counter problem and, repaired a bunch of bad solder joints on the bottom side of the board, and then I actually put it into transmit and put some modulation into it. Oh my God. This is like the third, I don't know, maybe fourth radio in a row. And it's not just new radios. The one I just did before this was a Browning Baron. That one was clipped. Just distortion out the yin-yang. And how many times I have to say this, people? When you do things like disable AMC circuits, disable ALC circuits, so basically the audio limiter circuits for your AM and for sideband, you will see more power on this watt meter. You will probably see more power on an external watt meter. The problem is your watt meters, don't want to be mean to the poor little watt meter, but it's stupid. Sorry, watt meter, but you are. You're a dumb meter. Somebody's got to be dumb, and you're it. So, the reason this watt meter is, and actually it's not dumb, it's doing its job. It's measuring, all that meter does is measure the voltage going to it, or actually how much current's going through it. There's how much current it takes to take this thing to full scale. It could be a milliamp, 10 milliamps, but whatever the current is. It doesn't know what it's attached to. It's just being sent voltage and current, and it reacts. The needle moves. The problem is that what it's sampling is RF power output from that connector right there in the back, out of the antenna jack. The main problem there is it's measuring everything that goes out that jack. So it cannot differentiate what frequency, that voltage is at. It doesn't know, is it a harmonic? It doesn't know if you're in sideband, is it IMD, intermodulation distortion? On AM, is it a distortion product? It can't differentiate, is it power that you want going out your antenna connector, or is it power that you don't want going out? And the problem is when you do these modifications, it looks great on these watt meters. It looks great on an external watt meter. It looks even better on a peak reading watt meter. Man, you'll see needles bouncing off the right-hand side of the meter face. Good grief, you'll bend the needle. You'll have a needle bending radio. The problem is, all of that newfound power isn't where you want it. You're talking in, and I'm going to show that, you'll have harmonics. So, if we modulate, let's say on AM, we modulate with 1 kilohertz audio tone. That's the standard for most radios, 1 kilohertz. That's what you adjust your AMC with. Well, once you get to the point where it starts to distort, you'll start to see other little peaks show up on a spectrum analyzer at even 1 kilohertz intervals heading out from that. That's because what's the harmonic, the second harmonic of 1,000 hertz? It would be 2,000 hertz. The third harmonic's going to be 3,000 hertz and 4,000 hertz and so on and so on. And that's what you'll see. You'll start to see all these peaks start to come up. So, when you're in AM, you'll have a carrier and 2 sidebands, the upper and lower sidebands. A lot of times what you'll see is these 2 sidebands, when you do modifications like this, that's where your information is. So, if you're sending a 1 kilohertz tone in, you want these to be big, your 2 sideband peaks. The problem is, you'll very frequently see those actually decrease when you do these modifications. What's making the watt meter needle go higher are all of the harmonics. So, there'll be a third one or a second one will pop up over here. There'll be another peak will start to come up really, really fast. And eventually it can get to be as high as this one. Well, that's going to be at 2,000 hertz. The next one over is going to be at 3,000 hertz. And if you go out to, let's say, we're in the CV band, so we're in 27 megahertz range. If you go out to the 54 megahertz band and look out there, you'll find another signal out there. Multiply the actual transmit RF frequency times 2, that's your second harmonic of your RF frequency. You're going to find, so if you're on channel 19, it would be 54.37. On channel 20, I think, yeah, which is what I have the radio on now, it would be, 54.41 megahertz. You'll see peaks popping up out there. And when they get bad like this one, shoot, you'll see peaks at the third harmonic and the fourth harmonic. And I've seen radios so bad they had measurable harmonics out to the 7th or even the 9th harmonic. I mean, just absolutely horrible. That's what I consider a splatterbox. And those harmonics, the actual audio harmonics, your distortion you'll see when you're in AM and sideband, that's what causes adjacent channel splatter. That's what starts to leach into the adjacent channel. So if you're on channel 19, it's leaching into channel 18, and not that there's a CB channel directly after 19. That's one of the A missing channels. But, let's say if we're on channel 20, you'll have power on channel the 19A, and you'll have power on channel 21. And if as it gets worse, it'll get wider. Just go down to the Super Bowl sometime, channel 6, and listen to those guys. You'll get some of those big-time operators keying up their 10 kilowatt amplifiers and splattering. Yeah, well, they splatter, and occasionally I'll hear guys where I can actually hear them 10 channels on either side of channel 6. You know what that tells me? The electric company loves those guys, because their watt meter, outside their house, not watt meter like this. The watt meter that hangs on the side of their house from the electric company, yeah, it's spinning, because they're sucking up some juice to run those big boxes. The problem is, something? Honestly, they're probably only putting out 1,000 or 2,000 watts on channel at the actual frequencies that they want. The other 8,000 or 9,000 watts of power is just everywhere else in the RF spectrum. It's doing them absolutely no good. That's why a large majority of those guys also sound so horribly distorted, gritty, like they're talking through a piece of crumpled up newspaper. That's because they're losing audio, and it's appearing elsewhere in the RF spectrum. So it's hard on equipment. It's hard on my ears. I can't stand listening to distorted people talking on distorted radios. But it's not doing you any good. It's ghost watts. Fake. It's not fake watts. It's not that the watts are the meters. It's not that these meters are lying. They're not. They're just, like I say, they're dumb. They're just reading all of the power that's there. They're not frequency selective. That's the problem. The only thing you can measure power in the frequency domain with, actually there's a few instruments, but the main one most people are familiar with would be the spectrum analyzer. You can actually see the peaks, where the power is at in the RF spectrum. There's other frequency selective meters that you can use, again, laboratory instruments. But the one where it's very easy to visualize is a spectrum analyzer. And then you can see your distortion just with nothing more than an oscilloscope. That's really all you need. And this radio just goes to prove that. So let's put it in AM. Let's see here. It doesn't take much to make this thing off, but this thing's just horrible. I'm setting up the audio frequency. So let me key the transmitter. Let's see, everything's hooked up. Yeah. Key the transmitter. And we look up here at the scope, and my camera's about ready to pop out of the mount. And just so you can see, this is actually the radio. Try and lift this up so you can see me. Now the scope's out of view. Get it up here so you can see me taking it in and out. Out of transmit. So, send, receive, transmit, receive, transmit. Okay? That's what we call box cars. Because you know what that looks like? It looks like a bunch of train box cars lined up beside each other. Rectangular boxes. That should not be rectangular boxes. That should be nice sinusoidal-looking waveforms, a modulation package, not rectangular boxes. That is just, it doesn't get any more distorted than that. That's just, wow, that's like the pinnacle of the perfect demonstration of how horribly distorted something can get. The other problem is if you look at it in the frequency domain. So I have this in spectrum mode right now, so spectrum analyzer mode. Alright, come on, camera. Okay, and I'm going to, again, now I have the span, actually that's the resolution, I have the resolution bandwidth set to 300 Hertz, so it's a fairly slow sweep, so we get a fairly detailed look. What you're looking at right there is actually the signal this test set's putting out into the radio. But I have the span set to 30 kilohertz, so that's 3 channels. So we'll have the actual channel we're on in the middle, and we'll have the 2 adjacent channels, one on either side. And I'll key the radio with, and what I'm feeding audio into this radio is 1000 hertz at 30 millivolts, which is normally when you're doing of radio alignments, they'll tell you somewhere between 10 to 30 millivolts of audio. Matter of fact, let's just turn it down. We don't even need that much, because this thing will actually is horribly distorted with just a few, with a couple hundred microvolts, honestly. Let's just put in 10. Okay, so now I'm going to be feeding it. So there's 10 millivolts of audio being fed into this thing. There's our carrier, there's the upper, there's the lower sideband. All of this other stuff we don't want. And this is all of the distortion products. But you can see, and actually this radio is out of alignment, which is something I need to do here. Let's get, okay, I'm trying to get the carrier centered. Okay, so yeah, the carrier is fairly centered right there. But if you look, you can see there's another peak at even intervals here, okay? And those peaks, you see, they line up. It's basically a mirror image of this, but a little bit smaller. And then the same thing, it's a mirror image a little bit smaller down here and down and down. That's basically all that is. That's, you know, here's your upper sideband. Right here, again, is your upper sideband. Here's the carrier, here's the lower sideband. Here's the carrier, the lower sideband, the upper sideband, and on and on and on. But it's harmonics of these frequencies here. This is all being shown. I need to feel how hot this radio is. Not too blazing hot, because actually I turned the power down on it. Don't want to be blowing out the finals in it. The problem is that's where your watt meter, it's not lying to you, it's showing you, it's measuring all of this. It's measuring all of this energy, but it's also measuring all of this other energy you don't want. This is distortion. This is just horrible sounding, because you have to realize the second harmonic of 1000 hertz is 2000 hertz. So that means when you're talking, if 1000 hertz audio sound comes out of your mouth, it will be reproduced there, but then you're also going to be transmitting a 2000 hertz tone, and a 3000 hertz tone, and a 4000 hertz tone, and a 5000 hertz tone. It's why it sounds distorted. You no longer sound like yourself, because you're transmitting harmonics of the audio frequencies that you're actually speaking. So when I'm talking, you know, if I were to hook a microphone up to this radio, it's going to be transmitting the frequency that I'm speaking times 2, times 3, times 4, times 5. And all of that extra energy is reflected in the, let me unkey this thing. It's starting to get a little warm. Let her cool down for a second. But you know, that is what you would want. You know, like I say, this is a signal, the generator part that's sending it out for the receiver. But that's what you want, basically. A carrier, sidebands, that's it. You don't want anything else on either side, ideally. Now, I'm going to set it up now to look at sideband. Let me change my first tone. Now, in sideband, you do what's called a double tone test. So in AM, you do a single tone. In sideband, you do a double tone. And when you do a double tone test, what you're looking, you pick 2 non-harmonically related frequencies. Can be any number of frequencies, like 400, 2500, 500 and 2400, 700 and 1900, 850 and 2200. But you want 2 non-harmonically related audio frequencies. And then, but what you're looking for is, you're going to be measuring IMD. You're looking for IMD, or intermodulation distortion. And that's the those two frequencies mixing, because when you mix two frequencies together, you get a sum and a difference frequency. So, subtract one frequency from the other and add them together. You get, the sums and the difference frequencies. And then you'll get harmonics, all of the harmonics of those frequencies. The harmonics will mix with the fundamental frequencies. So you end up with again, if the ALC circuit's not working properly in sideband, you end up with all kinds of distortion. And also in sideband, if your driver and bias, or your driver and final bias is not adjusted properly, again, you'll start to see a lot of IMD products in sideband, measurable IMD. Matter of fact, even if you go out to the 54 megahertz range, a lot of times on sideband, I've actually shown that, I think, once or twice in a few videos, where you can adjust the bias current, transmit in sideband, adjust your bias adjustments inside the radio for the driver and final for minimum output at 54 megahertz, and then if you go back and actually check the current, it'll actually be right around where the book spec says, 50 milliamps. But okay, so I'm now going to be feeding this 400 and 2500 hertz audio tones, at exactly the same amplitude. I'm going to switch to, let's see, what am I in there? Lower sideband, and I'm going to transmit again. And again, we have all kinds, and for starters, this radio's not even, actually, I can't even tell, it's so distorted. Again, we're still at a span of 3 kilohertz here, or 30 kilohertz, so we're still at 3 channels, total. The channel we want and the 2 adjacent channels, the upper and the lower channels. But I think this is the lower frequency and this is the upper. It's so distorted that the audio, you should have on a spectrum analyzer in sideband, when you feed it 2 audio tones of even level or amplitude, you should see 2 even amplitude peaks here that are exactly, and they'll be at the audio, so whatever your carrier is, plus, or depending if you're in upper, it'll be plus, if you're in lower sideband, it would be minus. But so in this case, there should be an audio, there should be a peak at minus, around 27205 is our center frequency, so there should be a peak at 27.205 minus 400 hertz, and another peak at 27.205 minus 2500 hertz. That's the 2 audio signals that are being fed into the microphone jack. And that's all we want, is those 2 peaks. All of this other stuff is IMD, and you can see there's even other little spikes down here. So, if I set the span down to just a single channel, 10 hertz, you can see there's other stuff down here. It's all fuzzy looking. But yeah, you only want 2 tones, this one and this one, and like I say, it's so bad that they're not even at the same level. The lower, because I'm in lower sideband, that would be the lower tone is lower than it should be, and you've got all of it just, yeah. And just out of curiosity, let me take it out of transmit, and let's actually go out to 54, the heck am I on, 27.205. So 54.41 megahertz. So this will be the second harmonic, the RF second harmonic. And let's again transmit. And yeah, again, it's all frequency. Let me just I'm going to turn the clarifier. I know it's unlocked. But yeah, there we can see. All of this is being transmitted as well. This is television. This is the old analog television, but this is out in the 54 megahertz television band. What good is that power doing you out there in television? You normally, when you grab the microphone for your CB radio, you're not trying to talk to somebody on television, because last time I checked, televisions don't have microphones attached to them. So, if somebody's listening to you on your TV, they can't respond back to you. So, yeah, it just, like I say, again and again and again. I just see these radios time after time. Let me turn it off here. Get everything unplugged here. And I can see what's been done to it. I can see, and I'll have to do a little bit more inspection, but I can also see somebody's been doing a bunch of, let me get a flashlight here. Get a little light down in here. I can see there's a resistor and a diode bodged together there. There seems to be a growth of resistors right here. It's like 2 or 3 resistors all tied together. I don't know what the hell they got going on there. There's another part actually missing down in there. Here's your AM regulator circuit. Yeah, I mean, of course, AMC ALC pots, you turn those, they do absolutely nothing. So yeah, both of those circuits have been disabled. And if you look on the bottom side, we'll just do one last, you know, to fan the flames in sideband. You know, they did their resistor bodge here for even more power on sideband, which, yeah, that more power, if you look at it on the spectrum analyzer, it's not doing you any good, people. So let me unhack this thing. Basically, it's not that bad. Now, it can be a bit of pain in the butt sometimes trying to figure out what somebody's done. You know, people say, oh, well, just put it back to normal. Yeah, that's easier said than done sometimes. If it's a normal modification, like a lot of people do, yeah, I know exactly where to look. That one's not actually a normal, that's not one you normally see. That one's somebody bird-brained idea up there. But it's obviously not supposed to be like that in that circuit. So, you know, it's just a matter of grabbing the schematic, looking, you know, seeing what parts are supposed to be in there and putting it back the way it's supposed to be from the factory, and properly adjusting the AM and sideband limiter circuits. If you ever open up a radio and you see all of your potentiometers and all these little trimmer resistors are all cranked like that at full rotation, you've had a screwdriver job. Now the good thing is usually if they're all just cranked at full rotation, that usually means they haven't done a bunch of modifications in the radio. They just took the covers off. They knew that if they, okay, we turn this up the whole way, that's going to maximum AM modulation, and they crank this one up, that's going to be maximum sideband power. But it's not modified, so that's fairly easy to just come back in, do like I just did, feed audio signal in, and just properly adjust these. The problem is, when I took the covers off of this one, yeah, they were just kind of in the middle of travel, and didn't matter if I turned them, they have no effect. That's because those circuits are just completely disabled. So let me get to taking a look at this thing. We'll get this put back to stock, and then take a look at it the way what it looks like once it's properly set up. Okay, so now it's a clean radio. It's putting out, actually, I had to actually go back at the video and look at it and see exactly what the peak was before, but it's clean. Now, like I say, a lot of times, and actually not a lot of times, most of the time when you do these modifications, the actual power that you want decreases. That's the biggest thing people don't realize. When you do all these disabling of circuits and high power modifications, the actual power that you really, really want decreases. The power that you don't want, the distortion products, they increase, which is why your needle starts, you know, you end up with a needle bender radio. So, I have replaced a bunch of parts. So, a bunch of resistors, and then a bunch of parts that seem to all be growing together here. Here's a resistor and diode bodged together. And then, this was kind of a unique one. This is actually what, you've seen me remove this modification before, but usually it's located on the underside of the radio. They'll have this bodged across the AM regulator. I guess they didn't have enough resistors to come up with the right values. Actually, no, that's not even parallel, because they got that to the other end. Yeah, it's kind of a unique way of doing it. Usually it's just a resistor and diode in series. But yeah, they've got a resistor and diode in series, and then paralleled across that, they have another resistor. But yeah, the end result, trash. And then, actually, though that was a part, that was a diode that was missing. These were modifications to the circuits, either different values. But this is these two. It's not much to look at there, but those two pieces of wire were a diode that was removed, and that had disabled the limiter circuits. So new diode was put in there, and you can get over here. You can see new resistor there, two new resistors down in there, and actually that polydip capacitor, another modification can't say I've ever seen before. That capacitor was just missing. It wasn't even there. So new one was installed there, and I'm putting the same exact input level into the radio. The camera's never going to focus on the analyzer there. I doubt you'll be able to see. I don't know. Let me see if I can do something fancy. No. Just trying to see if I can't get into the menu to change the white balance while I'm filming. But I'll just key the radio. So I'm sending in a 1 kilohertz tone again, and you can see nice, clean, non-distorted waveform. And if I come down here and adjust the AMC, you can see we can turn it down. That's down the whole way, and then there's up the whole way. And you can see it's distorted there. And I'll show you what that looks like on the spectrum analyzer. So looks like I need to actually adjust the triggering on the scope there a little bit. It's bouncing around a little bit. Right about there. You just want them to come down the waveform, to just pinch in the middle, just barely touch. But you never want to see that line in between there in the middle just become a flat line. And also when that becomes a flat line, you'll also notice is actually if I turn it back up, you'll notice the tops of those waveforms start to get clipped off. It's no longer a sine wave with a nice rounded top. You'll see it starts to what they call a flat top. Get my adjuster back down in here. So you can see the flat line in the middle, flat bars at the top. We're starting to kind of look like a bloated rail car, but they're not flat-sided, so, but right about there. Looks good. And if we look at that on the spectrum analyzer, this camera just really does not like the monitor on this thing. It's just so bright. Looks great in person, but man, the camera just really doesn't like it. It's a hard time picking it up because it blinds it. Yeah, you can see that. So that's properly adjusted. And now what I'll do is I'll increase. Now the thing is, watch down here. What happens when you start to overmodulate? Because as soon as I start to turn this up, it's going to start to, I've got the waveform adjusted for exactly 100% modulation. And when I start to exceed 100%, you're going to see all of this stuff that's way down here all start to rise. But watch what actually happens up here. Not much at all. Okay, you can see it increased a little bit. But where'd most all the power increase go? It's all down here. It's all in distortion. Okay, and you can see there's all these peaks here. These are just distortion, and you're going to be hearing that in your transient, or not you won't, but the person that you're talking to will hear that. And adjust it back down. Right about there, where we want it. So the largest peaks here to be expected. That's going to be the harmonic of the actual modulation frequency. This one right here, and then just continues on down. But like I say, that's where all your power, all of your power is going. It's all that increase is down here, and it's going to be out at 54 megahertz. Second, third, fourth harmonics. Especially as horribly distorted as this thing was, I'm sure it had measurable harmonics probably out a couple times. Again, I have the span set to 30 kilohertz here again. So actually, if we just go back to one channel, so there's one channel bandwidth right there. Now it is a little bit lopsided. You can see this peak is a little bit taller than this peak right here. Honestly, these radios a lot of times they're not the greatest radios in the world to start with. Honestly, you have a really hard time getting this balanced. That's just part of the cheap radio problem. Some are better than others, and actually I've seen ones that are actually a lot worse than that. And actually the same thing in sideband. So let me turn it off, or take it out of transmit. Put it in sideband, and we'll set this up for a double tone test now in sideband. And turn on the second audio generator. And we're now in the lower sideband, and we'll transmit. And like I said, you can see, yeah, it's still lopsided here. I actually need to, because I have not adjusted the bias yet on this radio yet, so I may be able to get all this down even more. Like I say, a lot of times the bias adjustment has a lot to do with it doesn't really affect the AM, but on sideband, if you get your bias currents out of whack on your drivers and finals, that can really destroy your transmit audio quality on sideband. And we can look at that on the scope. Yeah, actually that needs to be adjusted. Yeah, there's basically what we had before. That's the ALC cranked at full rotation. Yeah, flat bar. That's definitely distorted. Yeah, see, I can't get it to pinch together. It's just not. Yeah, that's down the whole way. And you can see, again, just like with AM, you'll start to see the tops of the waveforms flatten off, which is what you don't want. Because that's when you start to distort. Same thing, if you're looking at spectrum analyzer, you're going to see the same thing. You're going to see all the distortion products, and the harmonics are going to be showing up. But yeah, I can't get it to pinch together in the middle. And like I say, the actual two tones, if you look at them over here, they're not even in height, and it's getting, now that could be just an artifact of the radio. Actually, what am I sticking into this thing right now? 700 and 1900 hertz. Let's pick, let's go with like 500 and 2400. See what that looks like. Yeah, it looks about the difference is about the same, and you can see the frequencies are a little bit farther apart because I picked two different frequencies. We could go with like 850 and 2200. So there's 850 hertz and 2200. Actually, that's very close. And actually, I think with Galaxies, I think it's somewhere around there where they would normally have you adjust. That's the two tones around where they use it. And actually, that's fairly flat. So, yeah, that's actually not, it looks like it's actually not a problem with the transmitter circuit. That's a problem with, well, it's not a problem. That's just the bandwidth, the audio bandwidth of the radio. It's not flat in these radios. So apparently it's, the filtering in the microphone amplifier circuit is fairly steep shouldered. And it's really rolling off this low frequency, because we're in lower sideband, so that, this is the low frequency and this is the high frequency audio tone. So yeah, it looks like that's what it is. It's this frequency is, as I go lower in audio frequency, that peak's really getting low, and that's why, because it's the audio circuit's actually starting to clip that frequency off. That's almost perfect. And if you look at it on the scope now, it actually looks a lot better. Let me try adjusting it again. So, there's, with it down the whole way, and again, if we go up the whole way, that's full rotation, massively distorted. Right about there. It's not perfect, but like I say, that's mainly not a fault of it's not a fault of the limiter circuit. It's actually not a fault of the transmitter circuitry either. That's more of a fault of the microphone audio bandwidth limiting circuit. So the low pass filter in the microphone audio circuit. That's basically why you're getting a little bit of a uneven, kind of like my two fingers, the length of my fingers. The one peaks a little bit lower because it's just not as much of that audio frequency is actually making it through all of the the microphone amplifier circuit. Now that does go through two different paths, and actually that's one thing we can check. So we were having troubles at like 500 and 2400. So actually we can check that in AM. So let's see what they look like. What I'm going to do is put the radio in AM. We'll set this frequency for, okay, and I'm going to go into transmit, and you'll see basically the size of the blob. A non-technical term here. That's because it's going to change, because I'm going to change the audio frequency. So the higher the frequency, you're going to see those are actually going to get closer together because the frequency is going up. This is a very low tone. But now what I want to do is change that to a higher frequency. I'm looking at that up on the analyzer, and it's... Yeah, see at the low frequency there, it's having trouble. Increase it, it's almost... Yeah, once you get up to around 700 hertz, it looks like, you know, so another thing I could do is actually sweep an audio signal through it, you know, and actually see what the attenuation is. But yeah, so like I say, that's more of a limitation of the or filtering, and that's what the radio's supposed to do. They're supposed to, you know, limit the bandwidth, and that's the way they do it. They limit the transmit audio bandwidth on the radios. In sideband, a lot of that's controlled by your crystal filter. That limits the bandwidth, you know, suppresses the carrier and your opposing sideband. In AM, you know, or in sideband only, it's only amplified for a small portion of the amplifier circuitry here, and then it gets mixed in with your for sideband amplification. In AM, it goes through a lot more amplification, also goes through the audio amplifier, you know, AM regulator. There's a lot more circuitry in EAM. But, yeah, it's really apparent in sideband. AM, not so much, but sideband, where tiny differences in audio intensity or the level can really reflect, you know, in that. That's why those two peaks weren't exactly the same, because it's limiting it a little bit in the mic amplifier circuit. So, yeah, it's back the way it should be and properly adjusted. Now, actually, I haven't adjusted the rest of the RF amplifier chain at all. Like I say, I haven't adjusted the bias, so there's no saying that it may actually straighten out a little bit more when I adjust the bias and get that checked. But I just wanted to show again, and it's just time after time after time after time. I just get radio after radio after radio after radio that's horribly distorted. And somebody, I mean, unless somebody did this for themselves, which is doubtful. Don't get me wrong, there are people out there that can work on their own radios, but the majority of people, they're not doing this themselves. They're paying somebody to do this. People, they're ripping you off. That's the main point of this. Yeah, they're charging you for, don't get me wrong, they're charging you for some work. They're making an honest living. They're not ripping you off. It's not like they're not doing anything to your radio. The problem is they're doing modifications like this. You know, they're sticking 15 cents worth of parts in your radio and charging you. Now, the labor, don't get me wrong, it takes time. Just like me, I get charged for labor. But the problem is, the reason I say it's a ripoff, or it's not so much a ripoff. That's the thing. I don't want to say it's a ripoff. They're not stealing your money. They're doing work. They tell you they're going to do a modification, and they do it. It's a scam, though. They show you on the watt meter massive needle swing. Look, man, you brought your radio in, and it was only swinging to 12 watts, and now, good Lord, your needle's bent because it's pegged against the right-hand side. And another thing they'll do, just turn up the meter. I've seen that before. Actually, this one's up pretty blasted high, to tell you the truth. I've seen people do that. Radio that just had an alignment, it might be doing a 4-watt carrier, but the meter is showing like 8 watts. Well, the reason it's showing like 8 watts on the radio is because they just turned the meter calibration pot up the whole way. But that's the problem. These meters don't reflect where your power is. You do these modifications. Again, it looks good on a meter, sounds horrible on air, looks horrible on the spectrum analyzer, looks horrible on the oscilloscope. If you were to demodulate this transmitted signal and run it into, I can run it back up to the communications test set through the audio analyzer, you're going to see this just horrible audio distortion. Good Lord, this thing was probably at like 30 to 40% distortion. I can't even imagine how high the distortion would have been on this thing. 2 to 5% normal. That's going to happen. Most of that comes, especially in speech, your AMC and ALC circuits. It takes time for them to react. It's not instantaneous. So you'll get peaks. There's a delay before the ALC circuit kicks in. Same thing with the AMC. When you start to talk, when it hits a peak, a lot of times, like if you look at that on a scope, or if you have a monitor, a spectra, or a shoot, getting tongue twisted here. A station monitor, that's the word I'm looking for. Got so many of the blasted things, I'm trying to sit here and think what fronts of them say. Or if you have a station monitor that's meant to look at modulation packages, a lot of times you'll see that. You'll see really big peaks in your AM modulation, and then all of a sudden it'll get smaller. That's the reaction time of the AMC circuit. And there's a fine line. You can't make it too fast, or it really over limits the circuit, but you can't make it too slow, or then you end up with overmodulation or distortion on AM. So there's a fine line there. It's kind of like balancing on a knife edge. You kind of go for the best of both worlds. Fairly decent timing with but that doesn't affect the circuit too adversely. But yeah, so I'm going to say this one's good. I'll do the alignment now, get the counter module stuck back in this thing, and I got to put some foam back on the top because this had that black, actually, you look down in here, kind of hard to see in the camera, but there's just all this black. It had disintegrated. I took this radio off. My bench was just covered in black foam dust. So I sheared all that stuff. I need to get the glue taken off of there now and apply some new foam. And what that's for is so this box cannot touch anything in this radio. That's why they had this piece of fiberboard here. They mount these with either a plastic screw or a metal screw with a insulating washer like you would use when you mount a transistor. They have a piece of foam on the top of this box so it can't touch the top or the bottom cover. And then on the bottom side here, there was another piece of foam right here, so it can't touch any of the transformer cans down here, because you can't ground this can against anything inside the radio here. But, yeah, so other than putting some new foam on, I need to actually do a full alignment on it, and get her put back together, and it'll be ready to go. But there you go. Another one just goes to show junk modifications don't do anything but distort your audio, actually lower power, and make you sound horrible on air.